Hello. Hey, everyone. I'm James. I'm co-founder and CEO of a company called Bugsnag. Today, we're going to be talking about some deep internals of error monitoring in JavaScript. But hopefully, it's going to help untangle any problems that you have. So, yeah, I'll kick right into it. So, I run a company called Bugsnag. Bugsnag is a San Francisco-based developer tools company. And we help you detect and diagnose errors in your software. So today we're talking a lot about JavaScript error monitoring in the browser and in Node. But we actually support error monitoring in desktop, in mobile, in backend, in JavaScript, in everything. So we have plugins for every platform and every programming language that you can imagine. We're also hiring if anyone's interested in a job. Come and talk to us at our booth later today. But yeah, today I'm going to be talking about JavaScript errors and JavaScript stack traces. So, actually I'll skip back a couple here. Diagnosing errors in the browser and diagnosing errors in general is a difficult problem. Some browsers make it easy, some browsers make it hard. And isn't that the case probably with everything in browser JavaScript though? One of the key tools to JavaScript error monitoring is understanding what's happening and why it's happened. And to get that information, you need a few things. But before I jump into that, what the hell is a JavaScript error? Why do errors happen in the first place? So there's a ton of different reasons that errors can happen in your JavaScript application. There's some gross ones, like maybe you're using eval and you've got a typo in there. Don't do that. Don't use eval. But then a lot of errors are caused by just bad data. So you might be expecting a string, but you've got null data. That's probably one of the most common ones that we see in JavaScript errors. Or maybe you're going outside the end of an array, or maybe you've tried to request a URL when doing an AJAX request, and it's a typo in the URL. A lot of the time, this data is something you've set up at runtime. It's not something you have, you can test to every scenario before you ship out to production. But there's a ton of different ways you can cause an error. Most of them are thrown as an exception. And when they happen in production, it's a problem. When they happen in development, no big deal. So you guys are all probably familiar with this little developer console right here. But if you have an error in your browser, you fire open your developer console, no problem. You can see exactly what's going on in here. I'll go into the kind of structure of this in a second, but it gives you all the data you need to go and find and fix that error. Once you've shipped your code out to production, you're going to see a whole different array of problems. So production error monitoring, we like to call the Wild West of error monitoring. You go out to, kind of tying in with the Clint Eastwood theme there, you kind of send stuff out to production. You've got people running mobile browsers. You've got people running IE 5.5. You've got people running browsers you've never heard of. And then you've got this whole problem with the environment not being inside your control. What if people have run out of RAM on their browser and that's caused Chrome to crash? What if people have got bad data in their local storage and that's being sent into your application and causing a crash? There's so many scenarios where you literally cannot predict them all and test them all in development that you need to find errors in production. It's a little bit harder. You can't sit and look at the Chrome console for all of your customers in production. So how do we do this? How do we find errors in production in the wild? So luckily, JavaScript provides a couple of hooks for this in the browser. Number one is window.onerror. I'm not sure if you guys have seen this before. It's a callback function you can hook up that when an error happens or an unhandled exception is caused, it will fire this window.onerror. Modern browsers also support subscribing to the error event, so you can add an event listener to get the error event. There's a little bit of a problem with this because you want to see as much diagnostic and debugging information as possible. So this is what we want to see. We want to see the class of the error, the type of the error. Was this caused by bad data? Was this caused by a bad URL? We want to see a message that tells us what exactly was happening. And then more importantly, we want to see this thing at the bottom here, the stack trace. And that's what I'm going to be diving into a little bit in this talk. But what the hell is a stack trace? So when you run code, you run a series of functions. Function A equals function B equals function C. That sequence of functions is known as a stack trace. And the easier way to say that is, what the hell was running? What code was running when a crash happened? You need to know what code was running at the point of a crash, because you want to go ahead and reproduce these problems. So you want to come in and say, was this caused by me? How do I fix this? Can I put the same data into this function to cause a crash to happen? So stack trace is pretty much an essential part of the debugging process, but it's a little bit hard to get in JavaScript land. So can we always get one? Yes, but terms and conditions apply. So as probably everybody who's worked with browser JavaScript knows, the biggest problem is that you have to support N browsers. So there are good, bad, and ugly browsers. Chrome and Co do a good job, but some don't. So I'll kind of go into that a little bit now. So as of about 2 or 3 months ago, Firefox is in this club now. These callbacks I talked about earlier, window.onerror and adding the error handler, the event listener for error, now give you an error object. And an error object contains a stack trace. So great, if we are doing production error monitoring, we can hook into one of these 2 function calls, and we can inspect the stack trace. And at this point in time, it's up to you what you do with that. So presumably you want to send that error report back to your servers. Maybe you want to send an email to your developers saying, this happened. Or you use a tool like Bugsnag that does this all for you. I'll get to that in a minute. But in Chrome, in Opera, which now uses the Chrome engine, and in Firefox, no problem, easy peasy. Don't have to do anything. Unfortunately, some browsers make this difficult. So IE9 Plus and Safari support stack traces, but only when you catch an exception or catch an error in a try-catch block like this. So, okay, we can get half the way there, but what if we want to not wrap every single piece of code with try-catch everywhere? This is a pain. We don't want to have to do this. Almost certainly you're going to forget to put a try-catch block in. Almost certainly there's going to be errors happening in asynchronous JavaScript that you're going to forget and won't be covered in a try-catch block. So how do we automate this? So step 1, what we can do is we can wrap functions. Let's try and make a way to add good error monitoring to bad browsers. So what we've got here is we've made a function called wrap, and you can then pass any other function into wrap, and it will put a try-catch block in, but also rethrow the exception. So it won't change the behavior of your code, but it will allow us to get this error object, that catch E there, that error object that contains a stack trace, that essential debugging information. But we don't want to have to go and put wrap everywhere in our code. That's a big pain in the ass. Let's make this happen automatically. How can we do it better? Well, the cool thing about JavaScript is it's a prototype-based inheritance language. So we can do some crazy stuff like monkey patching or editing, add event listener, remove event listener. Now, you might think this is crazy. It is a little bit crazy, but it works, and it's really, really powerful. So that wrap function we built earlier, what we can do here is we can automatically wrap any callbacks that are sent into add event listener and a remove event listener. Now, you may not be using add event listener yourself, but the browser is. jQuery is. All Ajax events are using this. All DOM events are using this. So this is kind of like the low-level event listener function. Any code that is running asynchronously is going to go through here. So this is the place to hook into. So putting that all together, we can make a wrap function. We can add a new event listener. And then we're golden. Except on old IE, the bane of all JavaScript developers. So there's not even a stack trace in a try-catch block in old IEs, just to make this hard for you. So all you get is the error name and an error message. That's it. It's awful. But there are still many people out there using these terrible browsers, and we have to support them. So how do we do that? Let's get dirty. Let's make our own stack trace. Let's do an approximate here. So this is the final piece of the puzzle. The cool thing about old IE is that window.onerror is called inline. So function A called function B called function C, which crashed, then calls window.onerror. So we can actually do something really cool, and we can unwind the stack. So using arguments.callee.caller, this is a really cool kind of cool/scary feature of JavaScript where you can introspect the who called me as a function. We can build our own fake stack trace. It's not going to be as good as the ones that come native in the browser, but it's going to get us 90% of the way there. So we can say, right, let's look at who called window.onerror. Oh, it's function C. Who called function C? Oh, it's function B. Who called function B? It was function A. Got it. Now I know how the user got into this state. But putting all this together is a bit of a pain. So we've got something if we want to write this code, but we don't want to have to write this ourselves, right? So 2 things you can do. Number 1, go steal this code. We did all the hard work for you. It's on our GitHub. If you want to write your own error monitoring in production, it's out there. Go steal it. If you want to have a better solution, we've built it. So the cool thing about Bugsnag is we detect these crashes in every framework, every browser, every programming language, and then we group them together. Okay, my resolution doesn't look super great on here, but each one of these kind of rows in our dashboard represents a single error. So it doesn't matter if it happened in old IE, if it happened in Chrome, if it happened in Firefox. By using that stack trace information, we're able to group them all together and say, hey, this error is happening thousands of times or millions of times. Go ahead and fix it. But yeah, if you have any kind of questions, if you want to go deeper into that, feel free to grab anyone from the Bugsnag team. We're just over there. And if you want to nerd out about JavaScript error handling, come and say hi to me afterwards. Any questions in the meantime? I'll put the slides up after the presentation. And I'll make sure to link to all of the scary things, the automatic wrapping and all that kind of stuff. I'll link to the GitHub so the code's available. Any other questions? I mean, one of the things, the reason I said steal our code here, do you mean, sorry, the question? Yeah, absolutely. So the question was, is there any good examples of production code or open source code that handles errors really well? The idea behind a tool like Bugsnag is that you don't have to worry about handling these things very well, because we have a single script tag that you can drop in at the top of your page execution, and it just does all this for you. It automatically instruments try-catch blocks. It does everything. But in terms of good error handling, it kind of depends, and I know that's a broad question, but if you're using plain old JavaScript, there is no good example of good error handling, because everybody does some things their own way. If you're using a framework, if let's say you're using Angular or Ember or, not React, but Angular or Ember, these frameworks have a single place that you can hook into that says, hey, when errors happen in my JavaScript code, go and jump into this. So if you are using a framework, I'd recommend going and checking out the error handling callbacks that Ember or Angular or some other frameworks provide. And they have really good examples of here's where you should catch errors and here's how they end up in this callback. Cool. Does that make sense? Yeah. Awesome. Any other questions? Go ahead. Yes, we are. In fact, that might be a good example of error handling code that you want to take a look at. I don't know if I can pull this up here. This is Bugsnag's Bugsnag, right? So this is our JavaScript errors right here. And it saved us a ton. Like there was a really cool bad thing that we did. It only affected a couple people because most of the people who use our software are software developers, so they're using modern browsers. But we rolled out some code that used array.indexOf in JavaScript, which I think is an ECMAScript 5 edition. And it was just such a natural thing to do. And we were like, great, it works, it's all good. And then suddenly all these errors started coming in from IE9. And we were like, okay, let's jump in and fix this. We don't have array.indexOf, let's put it in there. But yeah, we definitely use it. We dog food, or what do they say, the nice version of that? Drink your own champagne. Any other questions? Yeah, good question. So we actually support, I mean, these are our ones here, but we support pretty much every platform, every programming language, every environment. So browser JavaScript, backend JavaScript in Node, all pretty much backend languages, PHP, .NET, Java, Ruby, Python, everything. And also mobile, so we support iOS and Android monitoring as well. So the idea is that we do all the hard work that's platform specific. Like, for example, JavaScript is a big pain. Mobile is even worse. And we kind of homogenize it and bring it into one nice, clean dashboard. Any other questions? Go ahead. Yeah, good question. So the question is there any technique for filtering out noise, like browser extensions and things like that? So there's 2 ways to do that. If you were going to roll your own, then you could inspect the errors and stack traces and the messages before sending it off to the server or to wherever you're sending it to. What Bugsnag has done is two things. Number one, we automatically discard Chrome extensions errors because they're just noise. And the second thing is we allow you to do things like domain whitelisting. So you can say, I only want to see errors that occurred on my website or my CDN or whatever. We also have a client-side layer where you can run code before any errors are sent off to our servers. So you can inspect what's about to be sent to Bugsnag and then strip it out. So this is junk, I don't care about this. And that also helps with things like stripping out sensitive information. Maybe you have credit card numbers or something like that. You don't want to ever send that off to a third party, so you can inspect that data and then stop it from being sent out. Cool. Any other questions? Go ahead. Yeah, it's a good question. The question was, how do we deal with minified code? So we use a lot of CoffeeScript at Bugsnag. Don't hold that against us. And we also obviously minify in production. But we support source maps. So I know this is a bit blurry here, but I don't know if you see /source here. What we do is if you use the source maps spec, and most tools that generate minified code automatically support this, you just have to do a -- source maps equals true or whatever at the end. We output a source mapping file. So that will say, this is your minified code, send that out to your customers, and here's a source mapping file that takes compressed function names and file names and line numbers and turns it into full ones. If you use Uglify.js or any of these minification tools, they have this built in. And what they do is they add a little comment to the bottom of your JavaScript file that says, here's where the source map can be found. And Bugsnag automatically ingests that and then outputs full code. So this was eventually bubbled up. This is an error that happened inside jQuery. But obviously, we're minifying jQuery. This is not what the code would look like if you were to look at the file originally. But we've automatically pulled out the source map, and then we're showing you the actual original unminified code, source code. That's something that is almost a whole other talk about that. That's kind of a real complicated thing to do. But again, we handle that for you. Yeah, any other questions? The question is, does this affect performance at all? So the techniques that I showed on the presentation back there, the only one that has even a minor impact on performance, and it adds 1 millisecond to every second, is in our measurement, is the case where we have to generate our own stack traces. Luckily, this only happens when an exception is thrown, and secondly, this only happens on IE below than 9, less than 9. So we think the trade-off is worthwhile to get that extra debugging data. Everywhere else, because we're hooking into prototype callbacks, the overhead is very, very minimal and not measurable in almost all situations. Go ahead. Basically, our script works in strict mode-ish, but obviously arguments.cooly and that kind of stuff is not allowed. What we've done there is we have a modern browser version of Bugsnag, and we have an old browser version of Bugsnag. If you're targeting strict mode, you can use the modern browser-only version, which doesn't have any of the trickery like this in here. All that means is you will lose out on seeing stack traces on old versions of IE, but if you really, really, really need strict mode, that's the way to go. Also, because all of our stuff is open source, you can download this, you can remove anything that has anything you don't like, any code that you don't like or cause strict mode violations, and you can host it yourself. Cool. Any other questions? Cool. I think that's it. Yeah, so give me a shout. We're over here, Bugsnag booth, if you have any questions or you want to talk more. But thanks for your time.